Good evening. Welcome everyone here in person and on Zoom. I'm Maria Prebellini, the Dean of the School of Architecture and Design at New York Tech, and I'm delighted to welcome you to the inaugural event of our Spring 24 lecture series. The School of Architecture and Design lecture series and events committee is chaired by Professor Atina Papadopoulou. And we also have a committee with several faculty members from the school really actively engaged and bringing us to our attention throughout the academic year, important and really distinguished guests and lecturers contributing to this event. I encourage everyone, particularly our students that are here tonight, but in general, the students of the school, to attend and take advantage of absolutely intriguing, relevant talks, lectures, symposia, presentations, and much more with distinguished guests and speakers. And we have tonight the launch of a relevant book, having the opportunity to learn what key industry innovators, professionals, researchers, academics, artists, scientists, and a broad range of experts and passionate individuals are doing and thinking will no doubt contribute to enriching the experience, the learning of our students, but also the scholarship and the interest of our faculty and inspire all of us moving forward. I have the pleasure of welcoming you to the book launch of our Associate Professor, Pablo Lorenzo-Eiroa. The book title is Digital Signifiers in Architecture of Information from Big Data and Simulation to Artificial Intelligence, recently published by Routledge. I want to express my congratulations to Pablo for this important milestone. He's a very prolific faculty and the director of our Artificial Intelligence Lab. Is a temporary title, right, Pablo? We are working and see what the evolution of that title could be, based also on the progress of the research that you are and other faculty are spearheaded in our school. I'm quoting the content summary of the book, if you allow me to do that. This book frames the discussion by addressing new means to understand and expand architecture authorship concerning the survey, information, representation, higher dimensional space, big data, and artificial intelligence in the pursuit of activating an architecture of information. Let me say quickly, and then I will give the floor to my colleagues, but I want to also mention that our school is at the forefront of the discussion on artificial intelligence that is infusing publications, programs, curricula, and also our discussions, dialogues, and events. And we, through the studies that we have currently going on this topic, we were also able to infuse our participation to major events, like, for example, the Biennale of Architecture in Venice, Il Salone del Mobile. We are preparing our participation there next month, international conferences, and in general, the visibility of our school is strictly related to topics like this one. Within our lecture series, we offer a platform promoting conversations and talks on this subject. And next week, for example, I will have the pleasure also to welcome Matias del Campo, presenting his latest book, Diffusions in Architecture, Artificial Intelligence and Image Generators, which analyzes the impact of diffusion artificial intelligence algorithms and generative image models in architecture. So we will continue the conversation on this topic. But I would like now to invite to the podium Professor Tom Berebes for the introduction of our now.
Moderating, I believe you're
Okay, so at this point, I invite Pablo. I'm sorry,
Thank you so much.
thank you.
Thank you so much, Maria. Thank you for all the great work that you're doing. And I hear not only from our colleagues, but from abroad, how well the school is looking. So I appreciate the opportunities to support this type of research, which is not common. I also appreciate the associate deans and my colleagues for being here and for being supportive of the research. In general, there is a discussion about the relationship between architecture and computation that I would like to pay attention to, particularly in relationship to what has been going on since, I believe, first 2013 and then 2017. I'm going to discuss my relationship. This is not an informative lecture as much as it is my journey in relationship to computation and architecture through many years, starting from Acadia, then in 2013, Architecture Information book with Aaron Sprecher, and now recently the book that Maria mentioned, Digital Signifiers in Architecture of Information. Today, I would like to focus on some few aspects, and it's still going to be broad, the discussion. So I ask you for patience and to understand basically the relationship between artificial intelligence, between big data and simulation, that I think that there is a little bit of misunderstanding. The book has several chapters, 20 in total, and the book basically discusses problems of representation. I understand representation as a performative problem, but still a problem of representation. So I want to make some clarifications in terms of that. There's also some chapters discussing semiotics. Semiotics not in a way that some colleagues perhaps understand it, but in a different alternative way, a critique of semiotics, by the way. Problems of dimension, and then problems of actualization relating to construction or robotic construction and fabrication. And the last chapters, which is what I'm going to focus in today's lecture, are the problem of simulation. What is simulation? What's the relation between simulation and optimization to be able to activate problems of artificial intelligence? The conclusion deals with problem of authorship, which I guess we're going to discuss a little bit more in the moderation. The first problem is this. I want to frame a particular relationship that I have with technology in general. I'm not a technologist and I'm not a cultural history theory person, but I try to articulate boundaries and dimensions between the two type of problems, between technology and culture. I don't believe in the silos of knowledge. I believe that we have to explore our relationship with different types of problems. And one of the things that I believe have been happening, especially with the internet and social media, is that we are tending to agree too much on too many aspects. So this lecture hopefully is going to offer a different dimension and a different possibility in terms of expanding relationship between computation and architecture. In the summer, I did a brief presentation on the book here also in the Venice Biennale, and I discussed more frontally the problem of natural language processing in relationship to image generators such as Midjourney. And I discussed what a genealogy of linguistics in relationship to computational visual semiotics, which relates perhaps more to the problem of text-to-image diffusion models generators that is so much in fashion nowadays. I'm critical of that relationship, of the relation between language and visual semiotics. And I developed a genealogy of how different philosophers, literatures, and architects and media technologies criticize the relation between language and visual semiotics. In that sense, we discussed in the summer the problematic relationship between Nietzsche and Wittgenstein. Of course, in the formula given by Saussure, the sign equals the sign over the signifier, right? Today I'm going to focus on a different aspect. I'm not going to focus much on that, although I'm going to show some problems in relationship to that. The other distinction I would like to clarify is that I believe that we are in a representation restricted reality. I believe that we can access reality only through representation. That separates my research from others that perhaps understand reality more linearly and more clearly, perhaps better than me. So in that sense, I understand that we cannot really access reality other than different types of semiotics. And I think that this is a human condition. I believe that mathematics, for instance, is a type of semiotics, which I don't agree with many, of course, mathematicians, that they think that mathematics is a discovery of the laws of the universe, for instance. In that sense, I believe that I'm trying to expand the way that we understand the relation between computation and architecture by identifying how the different semiotics play with each other on the relationship between the sign and the signal, which is a little bit difficult to understand. Perhaps the other clarification I want to do is that I usually speak very densely, and the book is more dense than the way that I speak. So saying that, I just want to say that I'm not going to focus in everything that is in the slides. I just leave it for you to see where you want to pay attention to, and then perhaps reach out to the book and find out more about the aspects that you may be interested in. The first problem that I identify in the book is the difference between computational linguistic semiotics and computational visual semiotics. I believe that architects, the interesting thing and the difficult thing about architecture is that we deal with visual logic. And that's not the case for many other disciplines, such as, for instance, computational linguistic semiotics, right? We code using a linguistic problem. And I believe that that's one of the first barriers in terms of how we deal with representation in architecture relative to computation. So I enumerated several types of genealogies of the problem. I explained already in the summer this. The video is online in YouTube, so you can look at what I said about this. But basically, the interesting revolution is that nowadays is that we're finally activating natural language processing, which is both an advantage, but also a little bit of a limitation and a curse, because that solidifies even more the problem. So today I'm going to focus on this, on what is the difference between linguistic semiotics and visual semiotics relative to computation. And then in another future events or in the book, you can find out how do we activate informational semiotic, which is the ultimate objective. Yeah. We're not sharing the screen? All right, so something happened. Sorry, 1 second. I thought that it was. It was sharing before. You got it. All right, so I don't know what happened. Apologize for the people online. It seems that we were not sharing. It stopped sharing for some reason. Something got clicked. I didn't realize. All right, so I was discussing this slide. I'm going to pay attention to certain problems to activate today the discussion in relationship, as I was saying, to the problem of simulation. I believe that the paradigm of, for instance, natural language processing and programming in relationship to, for instance, mid-journey text-to-image generators and diffusion models is that language becomes a kind of program, and we are programmed to speak to the world and about the world through linguistic problems. And the reality is that in terms of cognitive science, we even wire our brains in relationship to the grammar of the language in which we grow understanding the world, which is even a bigger problem. I think that in order to activate computational visual semiotics, first you need to develop signs and in relationship to signals, and then you need to resist the linguistic approach to computation. And that's perhaps the difficult thing today, to think in terms of language, of written natural language, and to think in terms of visual communication and visual languages. I believe that the translation that has been happening today with diffusion models is both interesting because, of course, it's easier to code, but problematic because it brings all the conventions of linguistics into architecture. I include in the conversation, in the discussion of the book, what is computational thinking, what are the different stages, and when to approach what. I also trace histories and theories of computation in relationship to histories and theories of architecture. And that's, to me, perhaps the most difficult task of the book. How to understand what happened in computation, what are the structures of algorithms, and how we deal with that. What happens with architecture once you filter all the visual thinking through computational linguistics or through visual semiotics in terms of, for instance, shape grammar and other systems. These are very generic descriptions of the way we have been drawing using the computer and before using the computer, problems of representation. And I discuss all of the forms in the book, and I try to problematize the relationship between data and model in the book. For instance, in problems of statistical analysis and problems of survey. I believe that we are not really in a moment of artificial intelligence yet, and I want to define what is artificial intelligence for me, but we are almost there, and we are approaching the problem through, of course, machine learning, which is based on meta algorithms. The biggest change nowadays is this one, is that before we used to do complex algorithms, and now the algorithms are self-editing themselves. Before we had few data, and now we have a lot of data. So that's basically the biggest revolution since around between 2007 and 2013, which Google actually figured out first. So what happens with the other revolutions of the 20th century, right, relative to data? The idea of the lecture today is to actually focus on simulation through thermodynamics. What is thermodynamics? And I'm going to give a few definitions that relate mostly to the work. You can read them here in the book. Basically, I'm going to show you how we are activating problems in terms of the second law of thermodynamics, which basically is a heat energy exchange in which the more amount of heat, the more amount of entropy. The problem of thermodynamics is that it's non-reversible, and what's interesting is that there are different systems that actually deal with that problem. These are the systems that I work with. There are other systems. These are the systems that interest me in particular and my research through perhaps 20, 25 years. One of the interesting problems about cell automation is that it deals, according to Wolfram, with the second law of thermodynamics. Basically, cell automation is a type of model, a complex type of model that is able to produce certain type of problems. And I've been working since I am 15 years old with cell automation, first with Excel spreadsheets and now more with automatic generators of different kinds. Automata theory is another problem that we try to discuss during the book. And here, von Neumann, to me, is a name that is repeated across the book, because not only because of the problem of thermodynamics, but because he was one of the first ones to figure out that you could use thermodynamics to actually resolve deterministic problems. Then we discuss a little bit of genetic algorithms and basically robotic sentinels through swarm problems. These are the types of simulations that I discuss in the book, and I want to introduce to you today. We understand simulation, virtual reality is a type of simulation. If it is not performative, right, there is not really a problem of simulation activated, but only a problem of interactivity. Computational fluid dynamics have been working since late 1990s, activates the second law of thermodynamics and entropy in terms of the problem of the progressive heat, but also the problem of disorder associated to that. Then we have optimization, simulation optimization, right? There are different things, and I think sometimes architects actually exchange the relationship between the two. I also think that one of the interesting things about cell automation is that simulation is site-based. That's the type of computation that I like to activate, meaning that the site of the computation, the computation level becomes a proposal for the next computational level. And then agent-based modeling of self-organizing, self-optimization relative to not only self-organization, but actually recognizing patterns and able to resolve a program. This is the type of simulation that I believe we are working mostly here nowadays, but this is the type of simulation that artificial intelligence aims to activate, which is von Neumann self-replicator. I believe that very few people understand this, and very few are able to activate this problem, which is an H+ program problem. Today, the type of artificial intelligence that we are dealing today is mostly related to big data and the model associated with how that data is being processed. So therefore, artificial intelligence today is big data plus, or let's say, data science plus computer science. It's not really computer science alone. And with that, it brings the full baggage of the data problem, which I think also architects have been avoiding. I got into big data very early on, around 2007, and I believe that helped me to understand different paradigms of what's going on today. And actually, I started working with repositories almost 15 years ago, which I think in that sense that put me in an advantage. Now, the difference between the data and the model, the interesting thing about artificial intelligence, and I'm not going to discuss all of them, but this is where we are today. We are not here yet, right, in the last stage that I discussed here, is that basically we can train repositories through artificial neural networks to recognize statistical problems, patterns in data that are not humanly observable, or they are not humanly processable, right? That they're beyond human understanding and human possibility to process. That's the revolution of the last 5 to 10 years of artificial intelligence. The other problem, apart from artificial neural networks, is the problem of convolution, which is how we are dealing with pixels, right? Pixels in themselves are type of signs that architects through image generation will like working with. But in general, large language models such as ChatGPT are in here, and convolution or neural networks that deal with the problem of recursivity through pixels are a different type of artificial intelligence and structure. I am trying to activate this type of paradigm, which is a paradigm of an artificial neural network that can deal in itself with the problem of entropy at the coding level, which is a Boltzmann machine, which is the most difficult thing that I'm doing nowadays. By the way, I just want to make another disclosure that the images that I'm going to show are not my latest research, because I'm trying to work more professionally with research and protect my research. So some of the work is actually 4 years old, and I'm not able to show what the latest work because of patents and things that I'm working on. But basically, diffusion models activate as a type of simulation that is also based on thermodynamics. That's what's interesting. I think that the most interesting thing about diffusion models is that we were able to activate von Neumann's paradigm, right? The fact that pixels become noise, and then a denoise function using thermodynamics is able to produce deterministic order out of a problem of disorder. So thermodynamics is across all the images that I'm going to show, even if it's not visible or perhaps not that clear. The other type of diffusion models that I've been working since 2017 are 3D point cloud models. And I've been activating actually thermodynamics, noise and denoise functions directly in 3D point cloud. By the way, I've been working with big data point cloud since 2012, which also gave me a little bit of an advantage because not only through LIDAR, I'm going to show some images, but also through big data at the level of the signal level, right? When we're going to discuss a little bit what I mean by that. And the last part of the conversation is going to be what's the future and how can we start activating quantum simulation, which is the next boundary in terms of artificial intelligence. We have bias in data, but also we have bias in models, and there are politics in relationship to that. The biggest bias that I anticipated or that I discussed in since actually late 1990s is that computation is a type of anticipatory model. For instance, software, you kind of know what you want to resolve beforehand. And that becomes a problem. Why? Because I argue that the softwares actually predict, obviously, they are prepared to anticipate, not to predict, but to anticipate what you're going to be able to do in that software. And therefore, that's the biggest bias. For instance, Rhino, AutoCAD, Maya, right? There are softwares that are prepared with a set of tools to actually anticipate what you're able to do there. The revolution of artificial intelligence is actually to get rid of that paradigm, to actually think a different relationship between data and model so that you can overcome the deterministic approach of computation. So since 2010, when I realized that that was the boundary, I've been working on the relationship between design as a signifier, meaning that each software is loaded with a sign, a certain type of way of representing reality, and that anticipates that reality. And therefore, when we design using background codes that are already anticipatory, we relegate authorship to the software designer. In that sense, my work in artificial intelligence has been trying to motivate and unmotivate the signs that become active through the conventions of software programmers. I'm trying to actually expand the relationship between how software programmers design the interface and how can we activate problems in between. One of the biggest problems of image generators today, text-to-image generators such as diffusion models or based on stable diffusion or Midjourney, is that there is semantic segmentation. Semantic segmentation is linguistic-based. That's the first problem. That is based on conventions of how the image is tagged in the repository relative to augmenting the bias. And we as architects, we actually want to do exactly the opposite. We want to deconstruct the conventional relationships between how people understand what a column is a column, or a door, or a doorway, or a window, for instance. And that's the thing that I discussed in the summer. In point clouds, we have a similar problem because if we use semantic segmentations in 3D directly, we also can identify, yes, column, windows, and so on, but that puts us back in a self-referential problem in which the convention becomes the activator of the design. In order to avoid that, we have been working with non-semantic visual semiotic feature recognition. The problem is that the advantage of large language models, the revolution, was that before AI was giving a lot of patterns that were not easy to identify whether the computer was giving you something interesting or not. And then large language models help designers to actually get rid of the noise of things that were not decipherable. So today, I believe that we are in a better position to work with feature recognition better than before, partially thanks to the large language models. Another thing that I discuss in the book is how to train repositories to actually recognize features so that you bypass simulation. These are problems that I discuss in the book. One of the biggest problems that I have in terms of how we deal with survey, right? I've been working on survey for almost 20 years. When you collect information via point clouds, a lot of people actually usually use voxels. And voxels have been a subject that has been discussed for many years, maybe 10 years ago. And my problem with voxels is that actually do a subsampling of the signal. In a way, the signal is of a lower quality, a symbolic type of signal. And what I'm trying to do is activate a more fidelity in the relationship between the sign and the signal. The first problem in survey, we did this with Andrew Saunders and Graziano Valenti in Rome. We did a 3D scanning of Baroque churches. 2015. I started working with this in 2012, but these are basically, it's a laser 3D scanning a building and producing billions of points. In this case, you have to then reduce it to be able to see and render. This is 250 million, but the actual database is much bigger than that. And then, of course, we started, the biggest problem was actually how to deal with that. It took me several years until 2017 to actually be able to activate machine learning in point clouds. And we started having very successful and interesting results. I'm not going to show today particularly history theory because I want to focus on simulation, but just to give you a sample of what we have been working on. Of course, this is for Romini San Carlo, and we took sections through the 3D scan, criticizing how historians understood the building, an old paradigm of history and theory, proposing a new paradigm of history theory, and a new model of architecture relative to evidence, right? So this is, the signal is direct, is not through photogrammetry. Actually, the laser is able to hit on the boundary and give a signal back. That means that is the most precise. The error margin is on a tenth of a millimeter, right? So it's very precise, and that allows you to actually inquire on the actual work of Romini, which is much more expanded than what historians usually understood, because there are much more dimensions in the actual building than in what has been said about the building. Another problem that I like to discuss in the book, and of course, if you're interested in certain aspects, you can reach out to the book and get into these problems, but it's the problem of the data in itself. The relationship between the data and the model, the data validation, which is to me a political problem, participatory data, and the problem of information related to data. I believe that the data and model problem, we are about to do something very interesting with it, especially in relationship to geospatial models. I work with site-based computation based on signals that we recover. This is actually GIS, which is a problem to me because most architects work with GIS. And what I'm trying to work with is actually the actual signal, which is to 3D scan the entire city. We have been actually developing our own repositories. We actually 3D scan many portions of Manhattan, and that allow us to confront relationship between GIS, which is mostly layers produced in a very conventional way, with our own signal, and produce maps that are unique or activate problems that are unique. These are API. This is Google API retrieving information networks. And for instance, API that now are partially closed, such as Airbnb or WeWork, that doesn't almost exist anymore. That allows us to inquire into the city in a different way, both in terms of a corpse, in terms of forensics, and to get an evidence that is a different type of evidence and a different type of sign in relationship to the type of signal that you're working with. Another thing that we did in relationship to that was to, in 2017, retrieve photos from Instagram and actually create, because we were able to tag the position where the photo was taken from, develop a 3D scanning through Instagram, which then around 4 years later started becoming very popular, and actually people and students of mine started developing applications to be able to do that. The interesting thing about this, today you can actually not do it so well because we actually access some servers in China sometimes, which today you cannot access. We also did thermodynamic readings of the city and started working more on the relation between data model in terms of what's going on today. So this is what I discussed in the summer in the previous presentation. These are the steps to activate what I call emergent programming. And this is an evidence of what I was able to activate back in 2022. The image is not the objective here. I think most people are interested in producing sexy images, beautiful images in Midjourney. I'm not interested in that at all. what I'm interested in activating is a definition of artificial intelligence. Here, the definition of artificial intelligence is that I was able to activate a program within a program, meaning that the program is not prepared to do computational fluid dynamic simulation, and I was able to activate tracers, recognizing background, foreground, and to actually activate what's called a sentinel, or a simulation of a simulation. I think that this work was groundbreaking. It's one of the best things that I was able to do at the time. This was very early, was before Midjourney was available to the public. I presented in Acadia, but the submission was late. And then other problems of relationship between simulation and optimization via Midjourney, but activating loops between the form of the building and the simulation, being able to activate self-simulation, artificial intelligence simulation. So in that sense, to me, the generation of images is a very low type of definition of artificial intelligence. The real definition of artificial intelligence is to actually develop a simulation of a simulation. We also, since 2017, we have been working with 2D to 3D, but for instance, instead of using these masks, which is a typical thing that happens with Blender, these are masks not produced in Blender, but in other software, I was more interested in creating 3D predictions, which is a total different thing. Meaning, instead of dealing with the 2D to 3D in terms of perspectival estimation, to actually do a real prediction of what's behind, right? And we were able to activate this very early on with a system that is available, but is very difficult to train. Actually, we ran out of resources training this because you need a lot of power, right, and money to actually be able to do this. We were able to do it in very low dimensional points, but proving the proof of concept, right, to be able to go from Midjourney 2 images to a full navigable 3D image. Also to predict, in other terms, point clouds, and to actually develop models with that. But the earlier paradigm of artificial intelligence before the data was this one, was cellular automation. And we work here in NYIT with the students in the thesis students to actually create self-simulation, right? But through a model, not really with data, right? These are robots that they've tried to find their way through things and try to optimize surfaces, in this case, related to a certain behavior pattern. We also did for the Venice Biennale 2021, we activated a simulation that was running forever, right? Activating the halting problem, whether knowing whether a simulation is going to finish or not. And created, for instance, the form of the projects in relationship to activating simulation at the model level, not at the data level, 2019, while I was working earlier on, but in this case, we were working with undergraduate students, so there was not simply enough time to actually train our repositories. The big data simulation problem is of a different kind. And I think that architects in general have problems understanding the difference between what Frank Gehry was able to do with optimization in the 1990s and the way that we should be working today. And I discuss in the book different types of simulation optimization paradigms and problems. We are used to wanting to have a design, and I think that our bias as designers is the first problem. For instance, we tend to optimize a form that we like. And the paradigm of simulation and optimization is not that. It's actually to confront our desires in relationship to tons of data. So if you optimize structurally, materially, anyway, thermally, a form that you like, you're not really activating the simulation optimization paradigm, but you're simply optimizing your desire. Obviously, there is a deconstruction of your desire through optimization, but not as much if you develop the simulation optimization in tandem with each other. I believe that designing through simulation, particularly I've been working since 1990s with computational fluid dynamics, is a different set of mind. It's pragmatic, meaning that you have to run the simulation in order to understand what's going on, and that's the most difficult thing, because sometimes it's boring and nothing happens, right? And pay attention to the big data, emergent conditions, observable scale limits, swirls, all kinds of problems. I've been activating this paradigm. So this paradigm I worked several years, almost 20 years. I've been activating this paradigm of the feedback between the two. But what's happening with AI and simulation, and what happens with simulation optimization in terms of AI, and the biggest challenge today, which is to activate Bateson's cybernetics of cybernetics, which is how to predict generative and predictive, the relation between predictive and generative double-blind adversarial AI. 2019, I want to show you projects that deal with simulation. This is structural simulation, robotic simulation, robots running on simulations, trying to activate different type of paradigms. These are photogrammetries, recovering features, trying to activate problems of Gaudí in Sagrada Familia relative to activating them structurally through feature recognition. Simulations of structural simulations of Gaudí Sagrada Familia, measuring the real building in relationship to the tools available today, and trying to measure when Gaudí had problems and did not really activate his catenaries, which were famous evidence-based design. We also played with Midjourney in relationship to that, trying to activate optimizations. These are more, if you want, contemporary animations, generative animations based on retrieving API. And developing our own simulations of simulations, trying to activate structural conditions via diffusion models. We also work deconstructing the relation between images and 3D, simulating our own structural algorithms, but also creating synthetic data. Nowadays, synthetic data is being used to save resources. We did that back in 2020, 2021, being able to predict, actually, to predict the simulation itself, right? Which is the most interesting boundary today in terms of AI, because if you know a little bit of simulation that I'm trying to get along, is that you cannot really predict a thermodynamic system, right? So the challenge is how to use AI to actually predict the thermodynamics and the emergence, which is the most difficult thing and more interesting thing today. The problem is this, right? We run 600, this is a synthesis, but this is step 600 and nothing really was happening, right? So you need to believe that something is going to happen when you train your repository, especially when you're dealing with 3D point clouds. And obviously here is decimated, subsample with voxels, but we were able, through a loss function, to activate certain problems of the simulation, here demonstrated in the stress, right? So we did the simulations, we trained the repository, and we were able to activate the identification of the stress in the point cloud that we actually predicted. Then we also work with students trying to recognize features and activate robotic fabrication real time, getting a signal and transforming that signal into the robotics and the 3D printing to actually create emergent structures that cannot be done in the computer, but can only happen in the fabrication process. Von Neumann's ENIAC in the 1940s already predicted that if you could do a weather prediction, you can actually control the weather, right? That was his objective, 43 to 45. And the question of the environment today, right, resides on that problem, on how we understand thermodynamics, how we understand simulation, and what we can do with it. These are simulations from 2015 at the Cooper Union with some students, in which we were trying to understand how to deal with the relation between simulation and architecture. This is the problem that we have today. I believe that we have an economic system that works very well for the 1% and leaves a lot of people behind. I think it's in conflict of interest with the environment. I believe that the crisis, we're not going to be able to resolve the crisis even with the greenest capitalism. And that those crises, if you look at the statistics of 2023, we are beyond the red flag, right? Meaning that by 2030, we may be running out of luck in the sense that the relationship between the multiple crises may start becoming correlational, like a neural network. And we do not have the resources today. We do not have the science or the models to actually resolve correlational crises. That's the challenge of simulation today. So we are in a non-predictable future in which we have multiple crises arising together, and we don't have a simulation engine that would be able to anticipate what's going to happen. Meanwhile, in architecture and urbanism, right, we are dealing with things, linguistic terms. We refer to nature as if we were not part of nature. We use systems of representations that are outdated in relationship to the crisis. And the geospatial sign and signal are not only a problem, but are dominated by very few companies. We all know the problems of emissions. 40% of emissions or more are done by buildings, while industrial activity and transportation are minor in relationship to that. We are going to have to double the surface area of cities in the next 50 years. And if we use the current environmental footprint of the United States, we need 5.1 planets, right? If all the population of the world will be living like we do today, we will need 5.1 planets, right? Which is something that we cannot afford. Therefore, I proposed something that is a little bit controversial, which is to develop united biomes of the world. We presented at the UN, and we are actually working in several papers in which I started proposing with a group to modify international boundaries to be able to activate continuity in biomes. If we don't do that, I believe that there's going to be more wars than the wars that we have today because of the amount of people that are going to be displaced. If you look, these are biomes across international borders, but if you look at the aerial photographs, there is a distinct way of how countries deal with biomes, sometimes ruining the biome and actually interrupting the environmental rivers. This is me when I was 30 years old in Buenos Aires. We developed an ecological park using sedimentation. And I continue working with problems of sedimentation, trying to take to the minor signal level, such as the particle, the sedimentation particle, how we can deal with the relation between simulation and optimization related to particles and computational fluid dynamics. These are particle simulations of 2010. In which we actually code each particle because we didn't have software to do it, and activating some emergent qualities in Midjourney, trying to activate particle simulation, different ways of understanding geospatial information in relationship to environments, semantic segmentation of sedimentation processes in 2015, different types of simulations to try to deconstruct the relation between the building and the environment, right? To see if the sign of the computational fluid dynamics could actually activate a different way of understanding nature. Environmental, this is heat island effect, skyline of New York. We did this a long time ago now. Identifying with very precise data how buildings were actually creating the problem, right? We also work with robotic sentinels. This is a repository that is almost impossible to get today. That's the other problem, that the data window is being reduced. So the data that we can access today is limited in relationship to how repositories were open earlier. Although there is much more data, the quality of certain type of data is more difficult to get, particularly from big tech. We proposed a new zoning for different from cities across the globe to actually relate big data and AI through a blockchain and propose zonings that consider environmental processes. So the zoning itself would be dynamic and map real time to be able to reduce, for instance, mobility, to optimize mobility in relationship to public transportation and private cars or taxis in order to work simultaneously with environmental conditions. Finally, I want to show you the last projects and then some problems of authorship in terms of what we have been doing here at NYIT relative to the virtual reality problem or the digital twin. These are projects that they think of the particle acquired via photogrammetry, via survey, but think of the problem of forensic architecture as a design problem in itself. So basically thinking that the particle being simulated and the sign and the signal acquired in the survey can actually become a motivator of a virtual reality environment. We actually, this is a project by one of Master of Architecture, Computation and Technology students, Salma Kataz, in which we articulate the relations between the Met Museum and the Guggenheim, trying to cross repositories with each other and allow a real-time simulation of the collections, which is what happens with these paintings, right? The paintings and how the building becomes involved, they start crossing each other. So conclusions. What are the problems and the paradigms and the questions? I think that while we try to activate sentient AI, and we are, I think we are not far away from it, and that's for some maybe scary, maybe challenging, but the relationship between predictive AI, right, and generative AI, I call generative AI emergent programming, because I think that Midjourney, if you use Midjourney in a regular way, it's generative AI, yes, but it's not emergent programming. And I think that if you start thinking in terms of emergent programming, you start crossing to the problem of self-simulation. And the challenge is how are we going to activate self-simulation with quantum computing, which is the next barrier. I've been working actually the last 3-4 years on that. I'm not going to share experiments on that, but that's the next barrier. I believe that we are here today. We are starting to activate the model morphogenesis, which is that the model starts changing in relationship to the pattern, the data pattern recognition. I believe that I was able to activate certain elements of this problem, activating self-simulation, but we are not here yet. We are not, obviously, if we were here, we would not be talking now because it would be an exponential explosion. But we are in this relationship. The brain multidimensionality is almost approaching the Internet of Things. And we are approaching the superbrain connection through interconnectivity and parallel processing. So the question is, what's going to happen between here and here? Nobody knows because it's going to be emergent. But I believe that we are touching on the boundary. I don't know when that is going to happen, when the real automata is going to happen, but we are starting to activate model morphogenesis. And if you understand von Neumann, every time morphogenesis happens, that can become exponential because there are algorithms that are self-editing, right, algorithms. And that could be exponential, right? Actually, there would be a moment in which it would be out of human reach. So the question here is, what are we doing as architects, right? What is our authorship in relationship to all these systems that we receive? And what's the relation between architecture and computation in terms of authorship? What I believe that I'm trying to do is to increase the design authorship relative to the system. Although that's questionable, I believe that the death of the architect was announced by Negroponte in 1976 when they claimed that autonomous computational systems were the real authors. As we activate autonomous systems, we are relegating authorship to the system that we are optimizing, right? So what's going to happen with creativity? We don't know. I think we are actually today, we're in a very creative moment. Creativity is expanding, but there is also a communication level between machines, because we are training machines to be more intelligent, and we are actually becoming obviously more dumb. The coefficient of intelligence lowered for the first time around 2004 due to microplastics, but also because of social media and the internet. So while we provide the elements to a digital feudalism that is going to control us, is already controlling us, we become relegated in terms of our authorship, but also our self-being. I believe that social media is becoming, it's actually creating synapses connections in our brain that is changing our brain structure, meaning that we are becoming used to behave like the algorithms that want us to train, right? Which is kind of crazy. We are actually training through human feedback reinforced learning those algorithms to become better, while our brain connections are being interrupted by predatory, right? Simulation engines that are designed to gather our attention. So I believe that there is a decolonization to be done in relationship to that. I am very critical of big data, of big tech more than big data. I believe that we should own our data and own our systems. And today we do not own our data and we do not own our models. We are carrying a cell phone that logs us real time against our own interest. And I believe that we are benefiting the 1%. So something has to happen in relationship to that. I believe that in architecture, we can activate what I call an ahistoric process in which the representation system, if we do not own or we do not activate our representation system, we're becoming colonized by big tech. And if we use the current available digital signifiers, which is the title of the book, the pixels, the point clouds, or the particles, we're actually relegating the means through which we actually activate the problems that we try to decolonize. So how do we do this? How do we activate an architecture of information, deconstruction of an architecture of information by following certain relationships with technology, understanding technology? I don't think that we need to be afraid of technology. We need to be afraid of big tech with the 1%. That we need to be afraid. I'm really scared of them, right? Because they're very powerful and they're more powerful. I believe that we need to understand what's going on, to expand history and theory in relationship to architecture, to expand our language and creativity in relationship to that. That I call a new expander grammar. In the summer, I discussed that, for instance, Sanskrit was a language that was used to expand the grammar. So in the year 800, people were already thinking that language was a limit to the representation of the world before Wittgenstein and Nietzsche, right? And I believe that we need to displace the digital signifiers, create our own signals and our own signs. I believe that computation and architecture are not the same. So how do we activate both architecture of computation, information, and how do we create our own system of communication? That's the challenge today. I believe that if you don't do that, you're not going to be able to do a cultural criticism, and you're not going to be able to activate the geopolitical economics. I believe that we are now seeing the legal disputes. OpenAI is being sued. I am part of a lawsuit. I actually was able to retrieve copyrights in images in Midjourney, denouncing the fact that actually if the copyright was visible through the API, that means that the generation was not enough to actually displace authorship, right, as they claim. So I believe that the digital feudalism is actually saying, yes, don't worry, the world is better, but as architects, we may disappear, not because of the technology, but actually because of the big tech. So in that sense, how do we elevate authorship? Who are the data validation systems that we have today? And I think that I'm not saying, you see, big tech is a problem, but the government is also a problem. I don't think that we have an ideal situation today. I think that we have bias everywhere. So how my contribution will be to create a blockchain collaborative intelligence, right? and activate a thermodynamic Boltzmann machine able to create a zoning system that can retrieve real-time ways to understand our urbanism. I believe that if we don't do that, this is what's happening. Architects belong to the working class, unfortunately. If architects develop their own means of production, meaning that if you develop your own media and your own mediums, which is what I proposed in 2010, you become a capitalist, right? So in both cases, it's a problem because you may become too powerful. Students of mine actually now were able to retrieve $65 million, right? They are 35-year-old students from Cooper Union with their own startup. So they're real capitalists. They told me, I'm going to do what you're saying. But then, yes, if you do what I'm saying, then you become a capitalist, which is also a problem, right? So how do we deal with that relationship? That's what the book discusses. So thank you for your patience, and I hope that we enjoy the conversation.
Thank you very much, Pablo. Do you want to take a seat?
Yes.
We'll maybe take a few moments and then take questions. So think of good questions. That was really an incredible presentation, super dense.
I'm sorry.
No, don't be sorry. You're really one of the pioneers in computational thinking, and you don't like calling yourself a technologist, but you are really one of the leading technologists in architecture. What's interesting is you cross these boundaries in a sort of disciplinary sense in architecture, that you've given us a presentation about the intellect of the thinker, about how the technology is formed. So your work in the broadest sense focuses on, as you call it, the architecture of information, at the intersection of architecture, computation, technology, history, theory, even though you like to sort of bounce between the two. The book relates to all kinds of domains of knowledge: linguistics, history, colonialism, capitalism, and the planetary consequences of the environment and our social order in the world. I've seen you for a long time, even before I even met you, as one of the leading thinkers and technologists in architecture. So it's really a pleasure to have you here tonight, but as a colleague. Before we open up to questions, I'd like to have some comments, and then maybe a quick question will open up to the audience. The book is written, and also your presentation tonight, you speak in a voice of the plural of we, and rather than the singular I. And I think that's really significant, not because you want to give credit to people you've worked with necessarily, which we all do, because I think it's significant in terms of the notion of authorship. So the sharing of credit, it seems, is indicative of collaborative forms of practice, in which shared authorship is a fact, and this predates maybe the fashion of the fashion of talking about authorship in the last couple of years with generative AI. The topic of authorship has become important, it seems. But you've been focusing on the question of authorship for some time, and digital technologies of the 90s certainly enabled the sharing of information and through models and data and such. But it also allowed for a way of working together and sort of, you know, as we talked about in the era of postmodernity, to relinquish authorship of the singular. And so the kind of team-based ethos of architecture gained a lot of value and force, and a lot of people believed more in collaboration than individuality. And that addressed very much one of the basic principles of how modernist pedagogy was formed, about the hero and the individual. And so it's fascinating hearing you talk about the context. And this context shifts from individuality to the collaborative ethos, in a way that, you know, where do we start this? It's not postmodernity, it's the 19th century. For some, we'll hear next week, Matias del Campo will talk about the 19th century and the notion of authorship within European philosophers. It also goes back to the Renaissance. For you, it seems like it starts with Nick Negroponte declaring the death of architecture in 1976, where he declares, as you do, that one need, with the autonomous features of computation, that we need to produce our, as you call it, our own means of production. You know, it's interesting that in the book, my reading was that that's what you need to do, but you're also critical of producing your own means of production. And so in a sense, you see computation as authorship. You argue for the need to author your own computational systems. You define diffusion or diffused authorship, collective authorship, authorship with no particular traceable origin. And the conclusion in the concluding chapter, the conclusion of your book, gives a really detailed and very precise account of your position on authorship. So the topic and even the complexities of authorship today become very fashionable and are current in terms of hashing these ideas out in a kind of new era where AI is without any drama revolutionizing many disciplines in architecture, certainly. And you've been very careful and thorough of these values and changing values and domains for many, many years. So I see yourself as really one of the experts to talk about, you know, how authorship and the notion has changed over the recent years, but over the last several decades. So maybe as a question before we open it up, about the consequences of authorship within a contemporary technological context. Could you summarize maybe with an audience of students, the issues, the controversies, the dilemmas of broadly working algorithmically over the last several decades, but also with the inception of artificial intelligence in architectural design thinking and working methods?
Well, thank you, Tom, for your comments. I really appreciate it. I think you're exaggerating a little bit about me, but I appreciate your sympathy about my work and my relevance. Just a clarification. In 2010, when I said that we were not the authors of what we were doing because the software was anticipatory, in Acadia, I did Acadia 2010 as a chair at the Cooper Union. Everybody wanted to kill me. They didn't really like it. Nobody liked it. Actually, my colleagues were very upset with me. And the software programmers, funny enough, they all agreed with me. But they did not want to say it publicly, right? They were all coming back to me, hey, man, you're right. You're the only one that is right. And my colleagues were all upset because I was saying that design was futile in relationship to the mega power of the software background, right? So then in 2011, Mario Carpo came up with a book discussing the problem of authorship, more similar to the notion that you're giving about collective authorship. I don't totally agree with that because the problem to me is that the fight is not only between collaborative horizontal authorship, because when you do that, but you use the software, the mega power of big tech crashes any collaborative. That was my discussion with Mario Carpo. I was not discussing, but we were emailing each other because I was going to publish an article at Yale and his students were there. So it was many years of discussion about that problem. I believe that the Renaissance was the first time, like Mario Carpo says, that the architect declared the authorship. Alberti invented that, right? In relationship to the building through notation, right? Representational notation, right? But Derrida, actually Ronald Barthes mostly, says, hold on, right? Because the author, when I do literature, Ronald Barthes says, the death of the author, literally in writing degree 0, right? also Blanchot and so on, right? The group of the 68 literatures, they identify language as the barrier of authorship. And that's what I refer to in the book. And actually, I've been talking about this since 2010. I think now people, it's becoming a fashion. I don't know why. I'm happy that it's becoming a fashion, but I've been talking about this for a long time. Just nobody really paid attention, I think. But what Derrida says is that there is no real, Barth says that the language is the author. That when we speak English, there is a set of grammatical structures that come through literature. Sanskrit in the year 800 already figured that out, right? The Sanskrit, a philosopher that was actually studying Sanskrit. Sanskrit is a language in India that is very old, thousands of years old, but it expanded the grammar to include multiple plurals, multiple genders in the year 800, right? Addressing the fact that he or she are a problem, right? And today we are talking about gender deconstruction. That happened a long time ago. And the language itself is the problem. Nature was also referred in different ways. When you talk with Incas, you know, the way that they talk about nature, they have no idea why we're talking about nature the way that we are talking about nature. So language is a barrier. Derrida says in relationship to that we cannot really trace any origin about anything. So the idea of author, in a way, is a colonizing project. Because when you say that you're the author, you're actually crashing history because it's impossible to be the author of anything. Derrida says that we are in a palimpsest of things and we cannot trace any origin of anything because it's very difficult. So when the computer gives you the sign, you start with a blank screen, right? With a pixel or a vector, you believe that that is the origin and the canvas is white or empty, when in reality it's full of a colonizing power by big tech that actually says that that is an origin, colonizing your architecture from the beginning. So that's the more what I mean about authorship, that I think that we need to deconstruct the signs. That's why the book is called Digital Signifiers. A signifier means that the sign speaks for itself. It says something before it's been said. So the pixel is already saying how we are structuring an image before that image is created. So that is the notion of authorship, which is very difficult to understand, that I'm challenging. I think it's different from other people that talk about authorship. And the Negroponte idea of the death of the author comes in which he's more like a technologist, more like a Patrick Schumacher, right? Like saying computation is going to run over everything, and that's good. And I'm not like that, right? I'm saying, hold on a minute, right? Like we need to be critical of that also. So I think that that's the kind of gap or niche that I want to activate.
Well, it's curious that Negroponte was working at a time of the height of artificial intelligence before all research stopped in the mid 70s until maybe until this century. Yeah, really, until the last few years. So there was a gap about 30, 40 years where Negroponte was at the absolute height of technological research in AI. And there just wasn't the power, of course, as you know very well, for artificial intelligence to advance beyond concepts.
Well, but in fact, the question is if we are really activating artificial intelligence, or it's just simply statistical pattern recognition.
Well, your lecture makes it clear that we're still in formation. We haven't reached that fully, and we're playing with some great new tools. Maybe we can open up the questions to our audience.
Anyone have any questions? Don't be shy.
You mentioned that the data is not owned by the public. We don't own the data owned by the big tech. How public can own the data? You want to dismantle the big corporation? Like AT&T was dismantled at one point for big power and did the regional telephone bell. Can you disintegrate this big corporation?
I think that I actually there is a lot of problems, I think. When I was in Spain, when the book came out, I got tired of giving interviews about that problem. I had like in 1 week, I burnt out 30 interviews in 1 week, because in Europe, they were actually discussing, it was the week in which European authorities were meeting about what to do with AI because of data, who owned it. And I told them, look, if you think that you're going to use Google and Facebook, good luck. Europe is going to disappear, literally, right? Because Europeans today, for instance, they use, that's actually the biggest strategic global thing that China did. China said, they cut them from the start. Nobody enters here, right? They actually have their own AI systems, and that's a discussion today. First of all, I believe that for sovereignty, to be sovereign, a sovereign nation and sovereign state, you need to develop your own data. How do you do that? It's very difficult, because unless you are China, that you have billions of people moving, you are not going to be able to create enough data to be able to activate statistical problems, right? So the first problem has to do with that at the government level. The other problem that I argue is that as architects, we need to gather our own data, right? That's why I do survey. I go around surveying reality and I develop my own repositories, and I train my own systems. Obviously, I cannot. The problem is that you cannot. Nobody can compete with big tech. So they are always going to be ahead of the game. I don't know if you are aware, but Google has been colonizing people like me. By the way, imagine if I am successful and I develop something interesting, either Google is going to steal or buy me out in an illegal way. That's what they do, right? Most of the people that were successful were either killed by big corporation. I mean, they don't let you go. That's capitalism. Is that? It's about unfair game territory. It's not really the American dream that we are used to. With big tech, you don't go through. You go through if you have somebody from up saying that you go through, right? That's what happened. That's what I believe that happened with my students. It's not that they were lucky and they did the right thing. They also have somebody that said you are going to go through, right? I don't think that capitalism in that sense is as clean and clear as people argue. And that the problem is more there than in the data development, because if it's very easy to actually tag our own data. It's very easy. Like, we should own our own data, by the way, right? That's what you're asking. And it would be very easy to tag it, to know what are the royalties that you get in relationship to how much you're training a mechanism. But that doesn't happen, right? And that's what I think is the imbalance, that collective intelligence is being used in a social way, activating all the problems of socialism, while it's being profitable for a capitalist top-down system. So the capitalist 1% is being fed by a socialist logic. So in other words, capitalism for us, but socialism for them, right? That's, to me, the problem that I think that the government needs to tackle. The fact that unless you are very clear about what do you do with the data, you're transparent about what do you do with my data, what are you using it for, how you're using it, and if you make profit, you need to pay me back. Midjourney is the biggest wealth of transfer of artists and architects to big tech. When I said that, it's the same thing that as 2010, everybody hate me, right? I was cut off, especially in the US academia, right? I was cut off automatically, right? Because I always say the uncomfortable thing in the perfect timing, right? That's how I am. And when I say that about Midjourney, everybody say, hey, are you crazy? It's like the most creative moment. I say, yes, but it's not fair, right? Because I use Gaudí, right? And I put very clearly, right? I'm using Gaudí's work. I'm trying to revive Gaudí and also breaking copyrights by using the system. But I think, to me, the issue is that we need to come to terms in terms of who controls what and who's in power, and how to activate a more collective agreement, not only authorship, but control. It's not authority, basically. I don't know. I think that the US doesn't have the solution. The US currently The other problem is why it happened in the US and not somewhere else. The biggest revolutions in AI are in the United States, right? That means that capitalism really works in terms of technological advancement, right? There is a Fordism that actually really works, right? Otherwise, China will have an open AI, and they don't. They have a similar one, but it's not as good as open AI. So obviously, there are advantages to capitalism. The problem is that the retribution is not shared, right? That's to me the unfairness of, and I don't think that the US was like that before. It was not always like that. The project of capitalism of the US was much more fair, universal, and social than the version that we have today. And I think that we're not going to be able to solve the environmental problem unless we address that, you know.
Other questions? Oh, plenty of questions. Thank you.
You touched very briefly on that. What do you expect when AI achieves singularity? And how far from today do you expect it to happen? And if it is bad, what is something that is being done at the government level that you are familiar that is being done? Thank you.
That's one of the keys that I discuss in the book. I put a date to burn myself, you know, to say that I'm wrong. But the problem is von Neumann, right, worked with the self-implosion of the atomic bomb, right? So we are in a very similar situation. They did not know at the time when they were developing the atomic bomb if the world was going to disappear, because there was a problem of self-replication. It could be exponential, infinite exponential, right? We are in a similar situation with AI because of recursivity and self-simulation. Literally, the singularity can happen. How can happen? I mean, depends on what you think. That's why I talk about semiotics, mathematical semiotics, right? There are certain definitions that I give in the book that they need to be complied with. I believe that I activated some of them. It depends on the definition, you know what I mean? It's also not human intelligence is being redefined because of AI, by the way, right? So we don't know really. The Blue Map project, which is the mapping of the human brain, did not finish, right? So we don't have a simulation, a full map and a full model of the brain active yet, right? So it's interesting that we don't know ourselves and we don't know AI, what is capable. The singularity, I believe, by the way, I know a lot about this problem because my mother worked with Bateson very early on in the 1970s. So I accessed very weird information very early on. My mother did her thesis on double-blind adversarial problems, right? So I was like kind of wired with this problem for all my life. And the interesting thing about double-blind adversarial problems is that they are exponential, and it is true, and some people actually do not understand that just the flow of information, just information movement, is believed to be the beginning of the activator of self-consciousness, right? Meaning that our brains are not as sophisticated as people think. We develop consciousness out of neural activity, spark connection. So we currently, that's why I put the dimensional problems that we are at. We are in the Internet of Things, meaning all the devices connected with each other. We are getting closer to the dimensions of the brain, the known dimensions of the brain, right? So once that information starts flowing in an adversarial way, that's what's believed to be the moment of singularity. The problem is that as any emergent problem, it cannot be predicted, right? It can only happen. I believe that the other misunderstanding is what intelligence is. I am not afraid of artificial intelligence because the type of artificial intelligence that I'm talking about is not cybernetics, right? That's why I put very clearly we are in a restricted representation reality. We are not representing reality. We are representing what we understand of reality. And the AI system is only going to be a mirror of what we understand. So therefore, it's not really the artificial intelligence of the science fiction. It's a type of mathematical recursive artificial way of understanding what we understand of intelligence. And I don't think it's going to compete with the human brain. I think that the human brain functionality, we are far away from that, and it's a total different role. And I think that very few people are taking that role. That's why I talk about the digital signifier. The digital signifier is something that separates us from reality. Baudrillard calls that simulacra. I believe that we are closer to activating simulacra than artificial intelligence. I think that the social media is a type of simulacra and is wiring our brains. That's the type of artificial intelligence that I believe we are going to activate. It's not a real sentinel artificial intelligence. It's that type of relationship with the world that is going to evolve into something that we don't know, but it's totally artificial because of semiotics.
Another question?
Yes.
Hi, I remember you guys were talking about how my question is what do you think is the problem in architecture that AI can solve? That opens a new door. For example, like just AI itself, right? It was blocked because there were not enough data. And later when data came along, and then they can inch forward a little bit. But the issue was computing power wasn't enough. So GPU and Vita came along. They're like, boom, we can do this in a second. Or 10 minutes instead of 10 years. So what is blocking architecture right now that you feel like AI can open up more door, or better word, machine learning or generative adversarial network? Thank you.
I think IBM was the first one to actually think about that problem. 2007, 2011, they mapped the entire building. It's a famous paradigm, and they put sensors everywhere. I think that we are in the Internet of Things. That's what the new Apple lenses are about. Are about being able to see what's happening at the sensor level. I think that as many senses as we have, the better. That's going to be a higher dimensional problem. And the retrieval real time is what's going to activate the next phase of architecture. But not only because of the chip limitation, right? The quantum is the leap to me. That's why I didn't really present it well, but the problem is, what do we do with the environment, right? And the environment is proposing the challenge and the solution, which is quantum computing relative to simulating multiple states at the same time. When we are able to do that, and I'm doing it with virtual machines, right? I'm doing quantum computing with virtual machines, the same way that we're working today with, you can do your own large language model with a virtual machine, right? Because you can make it infinite mathematically. The neural network can become very big. But to me, the Internet of Things, the sensors, once we are able to retrieve, that's what I was trying to do in 2017 with the Instagram, right? To be able to survey reality out of the Internet of Things. That's what big tech is doing, by the way. I don't know if you know, but all the systems that we have in our houses, they talk with each other illegally, right? Through the router, the Amazon and Apple, they're exchanging information without our consentment, right? It's like a dark level, right? So they are already activating that. You can activate a 3D scanning out of wavelength signals, right? So we also work with that. So to me, the boundary is there. Once architects, we are able to activate the real 3D scanning of the world relative to not semantic segmentation, the way that big tech is doing it, but going back to the old problem of artificial intelligence of feature recognition. Feature recognition, pattern recognition beyond human understanding, and a morphogenetic model, a model that can change in relationship to the pattern that is recognizing, which is the real self-simulation, right? Deep learning is about that. It's not about recognizing the pattern, not only the statistical problem. Deep learning is about activating the change of the criticism of the model, right? And I think Chomsky, by the way, he's the most critical of AI today. I think he's right. I think that my discussion with Mario Carpo the last time was that disagreement. He believes that Chomsky paradigm is out. I don't think so. I think that when we retrieve data, big data, the patterns that we retrieve, and the reason that what we select those patterns, we are projecting back again the grammatical structure that Chomsky referred to in his paper, right? I don't think that we are outside of Chomsky's paradigm, and I think he's right that we're losing a lot of time with things that all what we're doing in artificial intelligence today was devised in the 1970s, by the way. There's nothing really new. What's new is the amount of data, but the prediction scientists and mathematicians, they knew that with enough information in 1970s, you could actually predict patterns. They already knew that. The difference is that they were not able to do the proof of concept. Today, since 2007, depending how you count the Go game and so on, 2007, 2013, all the stages that we already know, the proof of concept happened, but the concept was devised before. And I think Chomsky is right that the grammar problem is still there. And he refers to actually the change in the model. That's what I'm trying to see if I can activate a morphogenetic model, a model that can change. I think I did.
Do you think Chomsky is so critical of AI? I've also followed what he writes in the last couple of years or so. And I've wondered, and I'll ask you the question, is it because of his deep understanding of language as a linguistic, or also, or his deep mistrust of capitalism?
Both.
Both, right.
And actually, but he was part of the thing. It was not us. It was Chomsky was part of the research. And, he wrote 3 papers, right? That changed everything. He did very little work. The work that we mostly know of about him is activism. But the linguistic paper, there were 3 bombs that he threw there, and then people pick it up. I think Minsky, right? The relation Chomsky, Minsky, there is a series of scientists that already figure out the problem of syllogisms and the problem of language in relationship to syllogisms, and how that problem is embedded in computation, that we need to get out of that. I call it non-linguistic. How do we get out of that? And I think that today we are restricted by that paradigm. We always do things that are outside of the paradigm in a way, right? And I think architects were the worst in that, because we are thinking in the optimization problem of the 1990s without thinking about simulation, because we don't understand thermodynamics. So I think that there's always a displacement in terms of what we really understand and what we activate. And I think Chomsky, to be precise, what Chomsky says is, which I agree, and actually Wolfram agrees. That's a weird thing. I found very few people that agree with what I'm saying. Wolfram is one of them. He says that out of the pattern recognition, the reason that why is for us of value, right? Otherwise, we wouldn't be doing that artificial intelligence. It's because of the grammar. So then every time we do a perceptron connection in the layer, in the artificial intelligence layer, we do it because of what we understand that we need, and that becomes the grammar. That becomes Chomsky's paper, basically. The artificial neural network, to me, that uses to train the data is the structure that Chomsky talks about in terms of the limit of grammar, is generative grammar. That's why generative AI, to me, when people talk about generative AI and they don't understand grammar, is because I think that they miss the cultural criticism of technology. And that's the biggest bias that we are today. Big tech grows so much, people don't read cultural criticism, and we are full of conventions by software developers that they are only interested in doing technological projects, training data sets, projecting all the conventions that we have been fighting against. And that's, to be honest, that's why I think the ultra-right is winning today. The ultra-right win politics is a consequence of that.
Maybe one last question? Or more if you want.
Sorry. Maybe there'll be two last questions.
So my question is, is this technology being used to collect data on energy systems within buildings and building materials? And if so, can it be used to test newly developed technology regarding sustainable architecture and the trends that they will have on the local and global environments?
Yeah, actually, what I tried to explain today was that, but I think it was not clear. But the Boltzmann machine is a type of neural network that I'm working with that addresses that problem. You know that we spend a lot of energy when we train a repository. So we are, with AI, we are destroying the planet today, right? We are putting too much environmental footprint. So to me, the solution is to create a machine that is able to produce enough energy to address a problem, but that understands the thermodynamics of the heat that is producing and is able to cool down in relationship to the environmental footprint. That's what I'm doing with it's a zoning blockchain platform that I'm proposing to coordinate all the zoning codes in the world, including the buildings. I think it has to be a commons. It has to be all the nations have to agree in developing an environmental simulation machine in which buildings and zoning codes are real-time collecting data and making a better performance of the building and the future building in relationship to how much energy is being put out. So that's a Boltzmann machine. Basically, the calculation is in relationship to the energy cost. And if we can do it, what I showed some images is to be able to activate that problem through prediction so that you don't spend so much energy. That's the challenge today. Yeah.
Last question. Professor Cody.
Thanks, Pablo. I think this is a very important conversation today. I don't know if there's a question or a comment. There seems to be a bit of a conundrum that we land in today, that the technology has formed all of these problems that we have, but yet the suggestion here is that it's the technology that's going to solve our problem. So how do we rectify that in our imagination? And I know that Negroponte had made some comments on this when he talked about, I think it was towards humanism through machines, and this relationship of what was happening in the technology and how we need to understand how we exist within that realm and how the technology needs to exist for us, not against us. So all of these things that you're saying and are suggesting is that the technology presents itself against us right now, and we need to formulate a new understanding that we can use the technology to evolve and move forward and advance into a new understanding of the technology working with us. Am I correct?
I think it's not the technology the problem. It's more the 1% the problem. Because and by the way, I define artificial intelligence not as a tool. That's the other difference of me and others. I think artificial intelligence is a framework, and in order to address what you're saying, the framework has to be environmental. That's what I'm proposing with the Boltzmann machine, that whatever we do, whatever machine we do, whatever technology we develop, it has to be an environmental framework. It has to consider the energy input and output in terms of CO2, not only in terms of the buildings that we build, but in terms of how we develop the solutions. And until we don't get there, I think we're going to fall into what you're saying. But the technology, the problem is not the technology. The problem is in the hands of who is the technology. It's, I think it's we are in a critical moment because the Ford anticipated what Google, Facebook, the six big tech are doing, right? Ford was the guy that went to the Congress and said, this is going to happen, right? And he invented Fordism, which is the problem of the United States, the problem of the growth of the United States, which is that because we are going to be so powerful, you need to give us both representation. That's what's happening in Congress, right? You have Congress people that are actually representing big tech. That happened because of Ford. Ford said that he invented the fact that representation was also a monetary issue. That if I develop enough money, I'm more important than the population. That's Fordism. And I believe that, I think that the Congress people, they actually believe in that. It's not only corruption. I think that they really honestly believe, and it's partially true that the US is a power force because of that. So, you know what I mean? It's like a double, it's more problematic. In other words, you develop a machine, capitalism, that actually works in terms of technology. You need technology and capitalism to be together. I discuss in the book, right? Otherwise, you cannot advance. But then the self-destructive power becomes so big that then it has a democratic representation. And I think that the crisis today is how do we deal with that? You know? I don't think technology is the problem.
No, it's not. Like, at one time, a hammer was technology.
Yes,
Depends on how you
absolutely.
use that technology.
Yeah, in the hands
For or
of
against somebody.
Thank you very much, Pablo. There's a book signing on, you can purchase Pablo's wonderful book outside.
Thank you so much. Thank you, Tom. Thank you, everybody. Thank you so much. I think the discussion was better than the